Okay. Are you able to see my slide? You are, right?
Yes, sir. We can see it.
Good. So we were talking about the endocrine system, and we said that the main organs of the endocrine system are the hypothalamus and the pituitary gland, and that is our area of interest in today's session. Okay. So the hypothalamus, okay, you need to know, at least have an idea where this hypothalamus is located. Okay, once you understand the anatomy, it will be very easy to understand the physiology. I've added some questions to show you as proof that if you understand these things, it will be easy for you to go through your MCQs question, the MCQ questions. Okay. So, like I said, this hypothalamus, whatever you learned in anatomy is true. The hypothalamus is part of the diencephalon, and you know that the diencephalon is made up of the thalamus. It's made up of the subthalamus. The hypothalamus itself is part of the diencephalon. Okay, so that is the anatomical part of the hypothalamus. But functional-wise, it falls under the limbic system. Okay, functionally, the way it functions, it falls under the limbic system. But anatomical-wise, it falls under the diencephalon. Okay, and you need to memorize these things like how much does it weigh. Okay, these are the things that can pop up in your MCQs. So you need to know that it weighs about 400 grams. Okay, so you need to know these small tiny things, because those are the things that might pop up in your exam. And I was using this diagram to show you where the hypothalamus is located. Okay, so this is where your thalamus is. By the way, this is the third ventricle. This is the third ventricle here. Okay, this is the third ventricle. So on top here you have your thalamus. Just below your thalamus you should have your hypothalamus. So the entire structure here is our hypothalamus, of which we say that it's part of the diencephalon, which weighs about 400 grams. Okay, this hypothalamus has a connection with this structure known as the pituitary gland. So you can see from this slide, the structure that has been highlighted in green is our pituitary gland. So there is usually a connection between the hypothalamus with the pituitary gland, as you will see in the other diagram. Okay, the functions of the hypothalamus, like I said, when you're talking about the hypothalamus in physiology, it has a lot of functions, and it is considered to be part of the limbic system. Okay, limbic system is that part of the brain that controls your emotions. You know, anything that makes you human being, that makes you as a human being, like emotions and whatever you get to feel as human beings, it's because of the limbic system. So the hypothalamus is part of the limbic system. But in endocrine, the area of focus is not everything here, but it will just be how it gets to control the pituitary gland. So whenever you're studying, it's okay to not know everything here, just to know, at least have an idea to say hypothalamus has a lot of functions. It's okay to know that. But the main function, the one we're interested in today's session, is how does it control the endocrine, okay, which is the pituitary. Right. So this other beautiful diagram shows a lot of things, but I want you to pay attention on one thing only: how the connections are between the hypothalamus and the pituitary gland. Okay, you can see that the hypothalamus has two connections with the pituitary gland. The first connection is in green. It's called hypothalamic-hypophyseal system. Okay, so there are things that are transported from the hypothalamus and they're taken to the pituitary gland. The other connection is this one that is in blue. Okay, it is the hypothalamic-hypophyseal tract. So take note of these two, but I'll be building up on these as we move on. Okay, that is why your physiology is, and you'll be getting all the questions correct if you just understand these. Okay, then forget about anything else you're able to see on the diagram. When you start neuroscience next year, we'll be able to talk about the rest. Okay, another thing I want you to pay attention. So this is still the hypothalamus. Okay, you can see here you have the thalamus. Okay, and then obviously this is our third ventricle. Okay, this is our third ventricle where CSF usually is found. Okay, and then now you have the entire structure that has been highlighted here with different colors is actually the hypothalamus itself. Okay, now you can see that the different colors that have been put here. I want you to know that the hypothalamus, this is very important for you to know, because that is where physiology questions are hard. Okay, I want you to know that the hypothalamus has different types of nuclei. What is a nuclei? Can someone help us out with the definition of what a nuclei is, based on our nerve physiology and our nervous system in anatomy? What did we say a nuclei is? Anyone? What is the definition of a nuclei in nerve physiology or in the nervous system in anatomy? Anyone, guys? Maybe the answers in the comment section. I'm just asking if you can show me the third ventricle it was cutting. The third ventricle, sir or doc, I don't know if it's a sir or a madam, or let me just address you as doc. It's this one here. That's the third ventricle. You can see this is the third ventricle here. On top of it, you have the thalamus. Below the third ventricle, you have your hypothalamus, which is this structure here. Now, in this diagram, you can see that this hypothalamus has different nuclei, should I say. Now, my question is, by definition, what is a nuclei in nerve physiology or in the nervous system in anatomy? How did we define a nuclei? Okay, without wasting time, we said a cluster of neurons, or we're almost there. So it's a cluster of the soma bodies of the neurons. Remember that each neuron has a soma body, which is the head. Eh? Now, a cluster of those heads, when those heads are together, like a lot of them are together, and they are found within the central nervous system, we call them as a nuclei. But if you have a cluster of the soma bodies outside the central nervous system, we call it as a ganglion. So those ganglions we've been talking about, they're also a cluster of soma bodies of neurons, but they're outside the central nervous system, so they are called ganglions. Now, the hypothalamus, because it's part of the central nervous system, it has a cluster of soma bodies. Okay, so these soma bodies are what makes up what is known as nuclei. So there are different types of nuclei that are found within the hypothalamus. Very important, because PGY will be asking you where the hormones are, where are they synthesized from? Where does the TSH say? Where is it synthesized? Where is TSH? Not TSH. TRH. Thyroxine releasing hormone, is it? TRH. Yeah. So you need to know these nuclei, because if you understand these nuclei, you'll be able to know which of these nuclei is able to synthesize whatever hormone you might be talking about. So to make it easier, I know this diagram has a lot of things. I just want you to concentrate on three things. Okay, I want you to concentrate on the different colors that have been put on these nuclei. The one that is more on the anterior aspect has been highlighted in green. So this is known as the anterior area. Just know it like that. So the anterior area has different types of nuclei. Okay, and then there is another nuclei that has been labeled in red. It's called the mid or tuberal area. Again, the mid or tuberal area has different types of nuclei. And then lastly, there is another one that has been labeled in blue, which is called the posterior area. So you can see they are just named based on anatomical position. The one that is in front, the one that has been labeled in green, it's called the anterior area. And if you look at the notes, below it, there's different types of nuclei. I'll come back to those. And then for the one that is at the middle, the one in red, it's called the middle. And then the one that is now on the posterior aspect is called the posterior area. These are the nuclei I want you to have in mind. Okay, at least you should know that the hypothalamus has three areas of its nuclei. There is an anterior area, there is a middle area, and the posterior area. Once you've understood that, I'll now move on to the next step. Okay, so again, this diagram that I've given you, the table here, it is representing the very same nuclei. The one that was in green, the one we called the anterior area, it is the one you're able to see in green, and it is showing you now different types of nuclei that are found in there. Okay, the one at the middle, the one that was red like that, it is the one that is being represented as red in this diagram table. Sorry, the one that is in blue, again, it is this one here. Okay, now this is very important. This is what I want you to memorize. From these nuclei, the one that is on the anterior, which is this one here, I want you to memorize these ones. Suprachiasmatic nuclei, it's a must know. Supraoptic nuclei, you have to know. Paraventricular nuclei, you have to know. No two ways about it. Okay? The ones I've ticked, which is this one here, this one here, this one here, you have to know. If I haven't ticked anything, you can forget about everything that I have not ticked. It's okay. So I want you to know that the suprachiasmatic nuclei, the supraoptic nucleus, and the paraventricular nucleus, they are all found on the anterior area of the hypothalamus. It's very important because we start talking about the hormones later on. Okay. Then for the middle tuberal area, the only thing I would want you to memorize is just this and possibly this. Okay, and then the posterior area, it's okay if you don't memorize anything. Just knowing that there's a posterior area without knowing anything what is found in there, it's okay. Okay, as you are preparing for the exam. So a quick recap. I want you to memorize to say that the hypothalamus has different types of nuclei. These nuclei can be divided into three. There is an anterior area, there is a middle area, and the posterior area. The anterior area, it has type nuclei I need to know for my exam. What are those nuclei? The suprachiasmatic nucleus, the supraoptic nucleus, and the paraventricular nucleus. It's a must that I know these nuclei. Why? Number one, the suprachiasmatic nucleus, it is the one that secretes releasing hormones as well as inhibiting hormones. What are examples of releasing hormones? A famous releasing hormone is thyroxine releasing hormone. Thyroxine releasing hormone is a good example of a hormone that is produced by the anterior area of the hypothalamus. Okay? Then you have another nuclei called the supraoptic nucleus. What does it do? It secretes two important hormones, and these hormones I must know: oxytocin and vasopressin, also known as antidiuretic hormone. You've been talking about antidiuretic hormone when you are doing your renal, right? You know that it goes to the collecting duct and causes reabsorption of water on that collecting duct. That ADH, where you now need to know where it's coming from. So it's coming from the supraoptic nucleus that is found on the anterior area of the hypothalamus. Okay? That's why you need to know this. Two, the paraventricular nucleus. This paraventricular nucleus is a must know as you are going for your exam. Okay? Because it has cells known as the magnocellular cells and the parvocellular cells. These magnocellular cells are the ones that also secrete oxytocin and vasopressin. Then the parvocellular cells, they are the ones that secrete all the releasing hormones. Releasing hormones like gonadotropin releasing hormone, thyroxine releasing hormone, all those hormones that have a releasing in them. They are actually produced by the parvocellular cells. Where are the parvocellular cells located? They are located within the paraventricular nucleus on the anterior area of the hypothalamus. Are we together? Guys?
Yes, sir. We are together.
Excellent. Okay. Anyone who is lost, okay, some people have confirmed to say we are together. Anyone who is lost, if you are lost, you are free to ask, and I'll repeat. In a case we've lost you. Okay. So if I haven't lost anyone, these are the only, and I want you to pay attention to. Okay, for now, pay attention to that, and I'll be building up on that. If I haven't mentioned anything when you're studying these notes, don't pay attention to whatever I haven't mentioned. So that when I'm creating notes, I have to. Okay, they were meant to. It was meant that I should teach everything, but because of time, we have to teach things that will come in the exam. Okay. Then now this is a diagram now showing you the connection of the hypothalamus with the pituitary gland. Okay. You can see from this diagram, beautiful diagram, by the way. Okay, that's someone at the question. So you can see from this beautiful diagram. Okay, I just want you to appreciate how the neurons, the tumor lines that are in yellow are actually neurons. So if you are unable to see, you can zoom your screens like that. Okay. So there are tumor neurons that are originating from these nuclei, the anterior, the middle, and the posterior, right? These neurons.
That's right.
Yes, doc. Yes. Someone is
Yeah, I didn't get the definition of a nucleus.
Oh, you didn't get the definition of a nucleus. So a nucleus, that's specifically when I talk about the nervous system. Why? When you're talking about the nervous system, whenever you hear a nuclei, it is a cluster, okay, or aggregation of soma bodies of neurons. Remember that each neuron has a soma body. Now, those soma bodies, when they are together and they are found within the central nervous system, we're going to call them a nuclei or a nucleus. But the very same aggregation, when it is seen outside the central nervous system, it is what we call as a ganglion. Those ganglions you've been mentioning in your anatomy. They are also a cluster of soma bodies, but outside the central nervous system. So we call them as ganglion. I hope it's clear. So now, because we're talking about the hypothalamus, it is part of the central nervous system. So the aggregation of the neurons it has, we are calling them as the nuclei. And then now we said that it can be divided into three zones: an anterior, the middle, and the posterior. But the physiology is mostly interested in the anterior area, because the anterior area has three types of nuclei we need to know. The suprachiasmatic nuclei, what does it do? It secretes releasing and some inhibiting hormones. I'll talk about them later. The supraoptic nuclei, what does it do? It secretes hormones like oxytocin and vasopressin. Okay. Then you have the paraventricular nuclei. What does it do? This paraventricular nuclei has two types of cells. It has the magnocellular cells, and it also has what is known as the parvocellular cells. The magnocellular cells secrete, are the ones that ends up secreting oxytocin and the vasopressin. Then the parvocellular cells are the ones that they end up producing all the releasing hormones. Okay? You'll see the hormones, the ones we've been talking about. So this is what I want you to take note of. Okay? And I also want you to take note of the ventromedial nucleus that is found on the middle and the arcuate, because of you'll see later why I'm telling you to know this. Then anything I haven't mentioned here, forget about it. It won't show up in your exam. Now, this other diagram is showing you the connection between the hypothalamus and the pituitary gland. Okay? So there are nerves that are coming from these nuclei going to the pituitary gland. Now, I need to mention here that the pituitary gland is divided into two. I'll talk about it later, but let me mention to say that pituitary gland is divided into two. There is an anterior pituitary gland, which is this one here. Then you have the posterior pituitary gland, which is this one here. Embryology-wise, the development of the posterior pituitary gland is different, and the development of the anterior pituitary gland is different. The anterior pituitary gland is develops from the pharyngeal apparatus, nasopharynx to be precise, while the posterior pituitary gland develops from the neural tube, so it's part of the central nervous system. So, because of that, the posterior pituitary gland, this one here, the posterior part, it is basically an extension of the hypothalamus. The nerves that are coming from the hypothalamus, they extend all the way back to the posterior aspect. While the anterior pituitary gland, because it develops from the pharynx, it has its own cells, it's different. Okay, so it is the one that will end up manufacturing the hormones that will be sent to go and control the thyroid gland, the hormones that will be sent to go and control the adrenal gland. They all originate from the anterior pituitary gland. But remember that this anterior pituitary gland, for it to be able to make whatever hormones it will make, we'll talk about them, it is controlled by the hypothalamus. So the hypothalamus, you can see in this diagram, it has tumor nerves. These tumor nerves that are on the anterior aspect, they are terminating on the blood vessels here. These are blood vessels, the ones that are in blue. You can see that these tumor nerves are terminating within these blood vessels, which is called the portal system. Okay? This portal system is the one that will now carry the hormones that have been released by the hypothalamus here, taking them to the anterior pituitary gland. And then the cells of the anterior pituitary gland will respond based on what type of hormone was released by the hypothalamus. And that is how the hypothalamus is able to control the anterior pituitary gland. But it's different. The arrangement on the posterior aspect is different. On the posterior aspect, the nerves of the hypothalamus, they extend from the nuclei all the way to the back. So in short, the hormones that are found on the posterior pituitary gland, guys, at least memorize that. The hormones that are found on the posterior pituitary gland, they are not produced by the pituitary gland itself. They are produced by the hypothalamus, because these are the nerves that are on the posterior pituitary gland. They are just an extension of the hypothalamus itself. Because the posterior pituitary gland, by embryology, it came from the neural tube where the hypothalamus comes from as well. So all the hormones that we'll talk about in today's session that are on the posterior pituitary gland, they are synthesized by the hypothalamus, not the pituitary gland itself. But the hormones that are on the anterior pituitary gland, they are actually synthesized by the pituitary gland itself, just controlled by the hypothalamus. I hope we are clear. Okay, so the functions of the hypothalamus, like I said, the functions of the hypothalamus is to control the pituitary gland. So it does two things. Okay, there are two connections with the pituitary gland. The one that is on the posterior is called the neurohypophysis. So the connection between the hypothalamus and the posterior pituitary gland, the one at the back, is called the neurohypophysis. Okay, and then you have another, so it's called the neurohypophysis because the neurons are the ones connecting with the posterior pituitary gland here, the neurons originating from the hypothalamus. Okay, then there's another connection called the adenohypophysis. So the adenohypophysis is now the connection between the hypothalamus in front here with the anterior pituitary gland. Remember I said that this connection that is in front, you have neurons that are terminating within the blood vessel, which is the portal system. Then these hormones are now taken to the anterior pituitary gland. Different from the posterior, where you have a neuron extending all the way to the posterior pituitary gland. Okay, so these are the two connections that you get to see. Okay, now control of the posterior lobe of the pituitary gland. So now I want to see or appreciate how the hypothalamus is able to control the posterior pituitary gland. Okay, so it all starts from these nuclei, supraoptic and the paraventricular nuclei. Okay, MCQs will come and ask you where oxytocin and vasopressin are released. So you have to memorize it. They come from the paraventricular nuclei and the supraoptic and the paraventricular nuclei of the hypothalamus. That is where oxytocin and vasopressin are synthesized. Okay, if you go back to this diagram or this table here, I ticked this one here, and this one here. They will secrete oxytocin and vasopressin. You have oxytocin and vasopressin. So we are talking about the posterior pituitary gland. So the posterior pituitary gland, these are the only hormones you ever see on the posterior pituitary gland. Oxytocin and vasopressin. Where do they come from? They come from the supraoptic and the paraventricular nuclei. Okay, these two nuclei, what do they have? They have cells known as the magnocellular cells. So these are the things I want you to pay attention. I want you to pay attention to the nuclei and the cells that are found on those nuclei. These two are the ones that will produce oxytocin and vasopressin, which is your antidiuretic hormone. What does oxytocin do? So oxytocin is the one that will end up acting on the uterus for contraction. It also acts on the mammary gland in females for lactation. Okay, for a woman to be able to produce milk. Okay, when I say produce, I mean the milk has already been formed, but just squeezing it out. Okay, just squeezing it out for it to be able to come out. It's because of oxytocin. Okay, vasopressin, you know what it does. It will go to the collecting duct of the nephrons so that water can be reabsorbed. At least this one you know. Okay, so this is a beautiful diagram. Okay, so you can see now, because we are talking about the posterior pituitary gland. So the hormones that are found here, we are saying it is oxytocin and the vasopressin, or ADH. Where are they formed? Where are they manufactured? They are manufactured in the neuroendocrine cells, neuroendocrine cell nuclei. What are those neuroendocrine cell nuclei? We said supraoptic and paraventricular nuclei. Okay, so once these hormones are synthesized, they are transported through these axons of the axons of these neurons, all the way back like that, and then they will be stored towards the terminal end of these nuclei. When it is time to release these hormones, the hormones will be oxytocin, which is oxytocin and vasopressin. They will be released into this portal system, which is known as the inferior hypophyseal portal system. Okay, and then now these hormones will go into the blood, and then now they'll go and act on the whatever organs that are getting. That's basically what you need to know when it comes to the posterior pituitary gland. Know that the hormones that are found there, they are not synthesized by the pituitary gland itself. It just acts as a reservoir, where this hypothalamus will be keeping its things, whatever it's synthesizing. So the hypothalamus makes oxytocin and the vasopressin on its neuroendocrine nuclei. Okay, once it makes it, now transports those hormones to the posterior pituitary gland. And it will wait for a stimuli. Once that stimuli is there, it will now release the hormones in blood, and then they will go to your breast, they will go to your kidneys to do their function. Let's now talk about the anterior. I'm hoping the posterior is clear. Let's now talk about the posterior, or the anterior, sorry. So the anterior is a bit different. The anterior actually has cells that secretes hormones. Okay, you can see the blood vessels in this diagram. You can see that the cells have been looped around. There is a looping within between cells. Blood vessels are looping around the cells. These cells are the ones that will end up producing hormones. Okay, but the pituitary gland, or the hypothalamus, sorry, has a control on how these cells should be producing the hormones. So there are cells, there are neurons that originate from somewhere here, but they do not extend all the way to the anterior pituitary gland. They terminate within the superior hypophyseal portal system. So these neurons, whatever they manufacture, it is always released into the portal system, and then the portal system will take now those hormones to the anterior pituitary gland. When the hormones act on the cells of the pituitary gland, the cells of the pituitary gland, which is the anterior, will start now synthesizing hormones needed to control the organs like the thyroid, the adrenals. Is there anyone who is lost before I move on? I want people to get this. Anyone who is lost?
I think I have a question.
Yes, go ahead, Doc.
I want you to clarify on where the nuclei I'm kind of confused because I thought there was supraoptic and then I found in the hypothalamus. So I didn't understand how they are related to the posterior lobe of the pituitary gland.
Okay. Are you able to see the diagram? Only I want you to zoom in this other diagram and to concentrate on the posterior aspect. And unmute yourself because I'll be asking you questions.
Okay.
Have you zoomed in on the diagram, right? Now, I want you to concentrate on the posterior aspect. Have you noticed that there are nerves coming from the hypothalamus? Okay? There are nerves coming from the hypothalamus and they're extending all the way to the posterior pituitary gland, terminating within the blood vessels.
Yes, I can see.
Now, these very same nerves, okay, they are originating from the supraoptic and the paraventricular. This part which has just been written as the neuroendocrine cell. It is the one we call as the supraoptic and the paraventricular nuclei. So it means this is where the hormones that are on the posterior aspect, they are all synthesized here, and then they'll be transported via these very same nerves you're able to see on your screen. They'll be transported all the way to the back, and then they are stored. They are not released. They will be stored towards the terminal end of these nuclei, just like how acetylcholine is stored at the neuromuscular junction. Remember that? Yes. So remember that even acetylcholine is synthesized by the soma bodies, and then it has to be transported from the soma body all the way to the neuromuscular junction and then to be stored. When an action potential comes, that is when now acetylcholine is released by the parasynaptic cleft. The same principle, the same thing applies here. So the neurons that are able to synthesize oxytocin and vasopressin are the very same neurons here, but their heads are located here, either supraoptic or paraventricular. That's what we said. When they synthesize these two hormones, they now have to transport those hormones towards the terminal end. And now once they have the hormones are on the terminal end, the only thing that is being awaited for here is stimulation, so that the hormones now can be released into the blood, the portal system, which is blood there on the posterior aspect. Is it clear now?
Okay. It's clear.
Okay, excellent. Okay. So, any questions? Okay, thank you very much for that question, Mong, and I'm happy that you are clear. Let me check in the comment section if there are any questions. Okay, there are no questions, so it means I can move on. Okay. So now, this is very important. We now know where vasopressin is coming from. We now know where oxytocin is coming from. But we need to understand how these hormones are regulated. Okay? How are they regulated? You know what vasopressin does. Vasopressin, which is your ADH, when it is released, it goes to the collecting tubules of your kidneys, of your nephron. And when that happens, there will be reabsorption of water. A lot of water will be taken back into the blood. Why does that happen? It only happens when your osmolarity, your blood osmolarity increases. If the normal is 300, if it goes above that 300, then these cells here, the ones on the posterior aspect, they are stimulated by an increase in osmolarity. And I'm specifically talking about the cells that are able to synthesize vasopressin. So vasopressin will now be released into the portal system here. It will go to the kidneys, affects the collecting tubules. And what does it do to the collecting tubule? It tells the collecting tubule to put in aquaporin, and then water will now start moving into the blood, so that water can now dilute that increased osmolarity. So in short, any change in plasma osmolarity will actually regulate the release of vasopressin, also known as ADH, which is produced by the cells of the hypothalamus. It is just stored on the posterior aspect of the pituitary gland. So there are a lot, and this now the thing about this topic, just me explaining this part, I've also explained the fluids compartment. These are the questions that are also seen under fluids compartment, but there's no way anyone who is first, you cannot understand this using that topic, the fluids compartment, sad, because there is a whole lot of knowledge you need to acquire for you to understand all this. Okay. Then oxytocin. What regulates oxytocin? Okay. So the regulation of oxytocin, like I said, whenever if a woman has a child, if they give their breast to a child and the child starts sucking, automatically that sucking will stimulate there's a reflex that gets to happen, and it will stimulate the hypothalamus. The hypothalamus, via these very same nerves, will be stimulated, and then they will release oxytocin. Okay. Another thing that regulates oxytocin is the sexual intercourse. Okay. Even when you're in love, it's also called a love hormone. Okay, because people who are in love, they tend to have a lot of oxytocin in their blood. So people who are in love, people that have sexual intercourse, suckling at breast, all these, they tend to release, they tend to stimulate the hypothalamus to release oxytocin in blood. Okay. Another thing that I forgot to mention is labor. The fetus, when it is almost term, it is able to release some hormones that will go and stimulate the hypothalamus, so that the hypothalamus can produce oxytocin, and that oxytocin will go to the uterus and start causing contractions so that the baby can come out. Okay, so those are the things I want you to know. Those are the things they'll ask you in your MCQs. Labor, how is it stimulated? The fetus is able to produce estrogen. This estrogen goes and acts on the hypothalamus. Hypothalamus will now secrete the oxytocin via the posterior pituitary gland. Suckling, when the baby is sucking, it can also do the stimulation. Sexual intercourse, and anyone who is in love. Okay, so this is a diagram now summarizing what I've talked about. So you can see that from this diagram, where is my case? Yeah, from this diagram, plasma osmolality has an effect on the vasopressin release, which is ADH. Okay, take note of this beautiful diagram. It's showing you that this first table is representing hypothalamus. The second table is representing the posterior pituitary gland. You can see that these hormones are actually synthesized within the hypothalamus, and then they'll be taken to the posterior pituitary gland, and then they'll be stored. They will now be released outside like that whenever there is a stimulation. So ADH is going to the kidneys. If it is oxytocin, where does it go? It goes to the uterus and the mammary gland. Okay, that's what I wanted you to appreciate. What regulates the release of these hormones? Plasma osmolality. If your osmolality is high, if an essay comes, if a scenario or a MCQ comes to say this patient or this person has 400, for osmolality is 400, then they ask you to talk about what do you expect the body to do. What the body will do is that it will stimulate the hypothalamus to release vasopressin, because vasopressin is the one that will reabsorb a lot of water. There will be reabsorption of water so that you can dilute that increase in osmolality. But if osmolality decreases, the opposite will be true. This hormone won't be released, and in short, you have little ADH in blood whenever your osmolality is low, because you want to lose a lot of water. M is trying to balance that osmolality. Okay, then sexual intercourse and suckling against oxytocin, and then take note that storage is always within the posterior pituitary gland. Okay, I think this is very, very clear. Is there anyone who is confused? And I want you to pay attention to say, when these hormones are released, they use systemic circulation, blood, for them to be able to reach the targeted organs. Is there anyone who is lost? Are we all together? The transportation between the hypothalamus to the pituitary is via what? Axons. But when these hormones are released, it is via circulatory system. Never should you forget that, at least until you write your PGY. You can forget afterwards. Okay? Okay, the silence means maybe all of us are clear. I'm moving on to the other part. Okay? So yes, Doc.
I've got a question. Why I think that plasma osmolality are they interchangeable with osmolality? Because most of the time in the papers I see osmolality and not osmolality.
Okay, so consider them to be the very same thing. Okay, whether you mean the one with an L or the one with an R, the point is still the same thing. Any change in either of the two will stimulate the hypothalamus.
Alright, thank you.
You're welcome. Okay, we now move on to the control of the anterior lobe of the pituitary gland. So how does the hypothalamus get to control the anterior pituitary gland? Remember that the anterior pituitary gland is actually a gland, the real life gland, not the posterior where it was just storing things. It's never manufactured. The anterior actually gets to synthesize hormones. Okay?
So,
yes, Doc.
So what did you say about the transport?
Transport of
The hormones.
On this diagram, I was saying when they are synthesized in the hypothalamus, just concentrate on the diagram. When they are synthesized in the hypothalamus, then they have to be transported to the posterior pituitary gland. How is the transportation? It is via the axons. It's called axonal transportation. This diagram is representing an axon of the neuron. You can see it was synthesized here and it has been taken here. Then it will be stored within the posterior pituitary gland. Then once this hormone now, let's assume there is high osmolality. Vasopressin has to be released so that it can go to the kidneys. So it will now be released into the systemic circulation, which is blood. Blood is the only one that will be able to go to the kidneys, and then that is how this hormone will be taken to the kidneys, collecting duct, and then the collecting duct will do the needful. So from the posterior pituitary gland to the targeted organ is via systemic circulation, but from the hypothalamus to the posterior pituitary gland is via axons. Hope it's clear.
Yes, thank you.
Okay. So now let's talk about the anterior lobe. Okay. So the anterior lobe of the pituitary gland, it releases. I was saying that it's the synthesis of actual hormones. Now the control is still by the pituitary gland, or by the hypothalamus. Sorry, the hypothalamus is able to control how the anterior pituitary gland is going to manufacture whatever hormones it has to manufacture. Okay, so the hypothalamus has two types of connection with the anterior pituitary gland. It uses what is known as releasing hormones. It uses what is known as inhibiting hormones. These two are what gets to control the anterior pituitary gland. These notes might not make sense. I'll use a diagram here. Okay, look at this diagram, and this diagram shows the connection between the hypothalamus and the pituitary gland. But what part of the pituitary gland? The anterior pituitary gland. Okay, so look at the first table, the second one, this one here, where the hypothalamus is. The hypothalamus has to control the anterior pituitary gland, and I said it does that using two types of hormones: the releasing hormones or the inhibiting hormones. If you look at the CRH, CRH stands for corticotropin releasing hormone. Corticotropin releasing hormone will targets the anterior pituitary gland. In the anterior pituitary gland, it will act on some of the cells that will end up producing what is known as ACTH, adrenocorticotropic hormone. Sorry. So adrenocorticotropic hormone is released whenever the hypothalamus releases a corticotropin releasing hormone. There is another hormone, a releasing hormone that is produced by the hypothalamus is called the TRH, thyrotropin releasing hormone. What does it do? It will go to the anterior pituitary gland, stimulate some of the cells to produce what is known as TSH, thyroid stimulating hormone. There is another releasing hormone called the famous one. This one you know it from embryology, gonadotropin releasing hormone. Gonadotropin releasing hormone will go to the anterior pituitary gland and stimulate some of the cells to produce what is known as LH and FSH. Okay, this LH and FSH, obviously, what is the target outside the pituitary? It will go to the gonads, which can be the ovaries or the testes. The TSH is the one that goes to the thyroid, and then the STH is the one that goes to the adrenals. Okay, you also have another hormone called growth hormone releasing hormone. I want you to pay attention. All the hormones that are coming from the hypothalamus going to the anterior pituitary gland, they are releasing in their name. Okay, we have corticotropin releasing hormone, thyrotropin releasing hormone, gonadotropin releasing hormone, growth hormone releasing hormone, and then you have prolactin, the last one here. It's called prolactin releasing hormone. What does it do? It can stimulate the release of prolactin. Okay, are we on the same page here so far? Anyone who is lost? We are good.
Okay.
Yes. Is it NSL? Are we are good or we are lost?
No, I've got a question.
Yes.
Here we didn't talk about suprachiasmatic nuclei. Is it also in relation? Because when we started saying suprachiasmatic, it's usually the releasing and the inhibiting hormones. You already mentioned it here. Is it also part?
Good. So he's asking a good question. When we started this session, I was emphasizing on the nuclei. I was like, you should know those nuclei. The reason why I was emphasizing those nuclei, I wanted you to know where these hormones are formed. So even if I don't mention the nuclei, you'll know where the hormones are coming from. Let me go back to the diagram, that diagram, okay? This one. Remember I said the anterior area, you have the suprachiasmatic nuclei. And then under suprachiasmatic nuclei, they are telling you to say, the cells under here, they're able to secrete what is known as the releasing hormone. So those hormones you are talking about, the gonadotropin releasing hormone, whatever releasing hormone that is coming from the hypothalamus, it can come from the suprachiasmatic nuclei because it is able to produce releasing as well as inhibiting hormone. The other nuclei that is able to produce releasing hormone is the paraventricular nucleus. But which cells? The parvocellular cells. They are all able to secrete releasing hormones. So I wanted you to memorize this so that when I start talking about the releasing hormones and inhibiting hormones, you already know where they're coming from. Is it clear? NSLT? And is it NSL? Yeah, NSLT. Okay. So never, as you are going for your exam, I can assure you, one of the questions that will come, they will ask you which of the nuclei is does get to produce those hormones. So I want you to know them like that. They are hard to, if when you get that book Canon of yours, the Canon book, and start studying, it's hard to understand what goes on. So I'm hoping it's now clear. Okay, going back to our diagram, which is this one. So these releasing hormones that have been the releasing hormones that are produced by the hypothalamus, the nuclei are those things you are seeing from that table. So either the supraoptic or the paraventricular, either of the two, they are able to produce these releasing hormones. So whichever you find in your MCQ will be the answer. When they are released, they will now go to the anterior pituitary gland to stimulate the production of SATH, TSH, LH, FSH, growth hormone, and prolactin. Now, I want you to pay attention to this diagram. This diagram is not for decoration, guys. Okay, it has you can study the entire endocrine just on this diagram, and you'll actually be able to answer all the MCQs. I want you to pay attention that SATH targets the adrenals. And when it targets the adrenals, what happens with the adrenals? Okay, I will be going through them one by one. The adrenals, you might not have time to go through everything, but take note that the adrenal gland has 3 layers. The adrenal gland has 3 layers. The outermost layer is called the zona. Anyone help me out? What is the name of the first layer of the adrenal gland? Zona what?
Glomerulosa.
Zona glomerulosa. Okay. What does the first layer do? It is the one that produces aldosterone. Okay. And then the second layer is zona
Fasciculata.
Zona fasciculata. Zona fasciculata is where cortisol is produced. Okay, so if you are studying, you ever read about the hormone called cortisol, know that cortisol is produced within the adrenal gland, but where on the adrenal gland? Zona fasciculata. Okay, then it has now the last layer, which is called zona reticularis. Zona reticularis produces androgens, the very same androgens that are produced within the testes. The very same androgens produced in the testes, they are also produced in the adrenals. And those androgens that are produced within the zona reticularis, within the adrenals, they are the ones that are responsible for secondary sexual development in females, like pubic hair. Okay, you know, females, they don't have androgens, they have ovaries, and ovaries produces estrogen. So where does testosterone comes from, which will cause them to have armpits in the hair in the armpits and the pubic hair? It is the androgens that are produced within the zona reticularis. Very important, never should you forget that. Okay, now I want you to pay attention to say that for the adrenals, where is my case? For the adrenals to be able to produce this cortisol, for the adrenals to be able to produce the very same androgen I have mentioned, for the adrenals to be able to produce, just these two, for the adrenals to be able to produce cortisol and the androgens, they need to be stimulated by a hormone known as the adrenocorticotropin hormone, which is this one. Where does it come from? It comes from the anterior pituitary gland. But this one, it can only be released when there's another hormone coming from the hypothalamus. So the corticotropin releasing hormone is the one that tells the anterior pituitary gland to produce ACTH, and ACTH will go and act on 2 areas. Remember, I've said adrenal glands have 3 areas, but I'm mentioning to say that ACTH will only act on 2 areas, which is zona reticularis and zona fasciculata. Zona reticularis is where your androgens will be produced. Zona fasciculata is where your cortisol is produced. This ACTH does not act on the first layer, which is zona glomerulosa. Aldosterone, you know at this particular point, because you've done your renal physiology, aldosterone release is independent of ACTH. Aldosterone will only be released when there is high levels of potassium. I think we did this under fluids compartment. High levels of potassium can stimulate the release of aldosterone in the zona glomerulosa. Or when there is low osmolarity, low levels of sodium in the filtrates within the nephron. Again, take note. I'm saying when sodium is low in the filtrate, I'm not talking about the blood. When sodium is low in the filtrate, that fluid that has been filtered by the kidneys, it passes through the nephron. When it reaches the distal convoluted tube, there is what is known as the macula densa. Macula densa is very sensitive when it comes to sodium. So when there is low sodium in that filtrate, it will activate the renin-angiotensin system, and eventually that renin-angiotensin system will cause the release of aldosterone. So my point here, the reason I've taken time to mention this is because I want you, the famous MCQ question, and you might get them wrong. ACTH has nothing to do with aldosterone. Aldosterone, what controls the release of aldosterone is a different system, which is the under renal. But that other layer, zona glomerulosa and zona reticularis, they are controlled by ACTH, which is also controlled by CRH. I'll move on to the other one. TSH. Okay? TSH is a hormone that is produced by the anterior pituitary gland, but it can only be produced when a hormone coming from the hypothalamus known as the thyrotropin releasing hormone is produced. So this TRH will go to the anterior pituitary gland to stimulate the production of TSH. The main purpose of TSH is to control the thyroid gland. That's all. TSH targets the thyroid gland. When the thyroid gland is stimulated by TSH, it will produce the thyroid hormone, which is T3, T4. The details about this now, you can now go to the video for thyroid gland. I think I did a good job with that. Okay. Then you have the gonadotropin releasing hormone. So now these are the ones that will go and stimulate the production of RH and FSH. Now these ones, they only stimulate the ovaries or the testes. You know what happens next with this. Now I want you to pay attention that growth hormone and prolactin. Have you seen now the other hormones you're about to mention, the ones that are produced by the anterior pituitary gland? Growth hormone and prolactin, they don't have any targeted organ. When I say targeted endocrine, like they don't have the targeted endocrine organ that will now again target another organ. They directly target tissues. Look at the growth hormone. What is it targeting? It's directly targeting growth plates. So this growth hormone is responsible for growth, right? That's the reason why it's called growth hormone. Then prolactin is the one that causes the production of milk. So for a woman, for the woman to be able to produce milk, it is prolactin. Don't confuse prolactin and oxytocin. We said secretion of milk, for milk to be able to come out from the breast, it is oxytocin. But production of that milk is prolactin. And the prolactin is released by, it's synthesized by the anterior pituitary gland. Now I want you to pay attention to these very two hormones to say that there are other additional hormones that control, there are other additional hormones coming from the hypothalamus that gets to control these two hormones. They are called inhibiting hormones. There are my red arrows showing. Inhibiting hormones. There is somatostatin. Then you also have this other hormone here. Okay. Yeah, there is somatostatin. Somatostatin is for the growth hormone. So somatostatin is going to the growth hormone, and then prolactin inhibiting factor is going to the prolactin. Somatostatin. So here, hypothalamus is ever producing somatostatin. Somatostatin inhibits production of growth hormone. So in short, the cells that are able to produce growth hormone, they are ever in inhibition. So they can only release that growth hormone when this inhibition is removed. Then prolactin as well is the same. Dopamine is ever inhibiting the release of prolactin. As long as dopamine is there, prolactin will never be released. As long as dopamine is there, prolactin will never be released. So you can only release prolactin when dopamine is scrapped off. So these two hormones are called inhibiting hormones. And I told you, I want you to memorize where the inhibiting hormones are produced. Okay? Going back to this diagram of ours, I said the inhibiting hormones, they are produced by the suprachiasmatic nucleus. Okay? You also have the... Where is that other one? Nucleus that produces inhibiting hormone. Okay? But the suprachiasmatic nucleus is like the major nucleus that produces those inhibiting hormones. So I just want you to know these two. Somatostatin and dopamine. Okay, dopamine is the one that will inhibit production of prolactin. It's like prolactin is ever there, but for it to be released, you need to remove dopamine. Growth hormone is ever there. For it to be released, you need to remove your somatostatin. Okay, you will enjoy your MC. If you've understood this, I can assure you, what they say that you want to read your basics. These are the basics they wanted you to read. And if, as long as you've understood this, I don't think you have any issues with your basics in endocrine, the ones you have to read. Okay, are we together so far? Okay. Okay, I'm moving now. I had to take a bit of time for me to explain so that people get it. But I'm hoping everything is clear here, guys. Okay. So after talking about these hormones, we now know these hormones are produced by the anterior pituitary gland. Okay, while these hormones are produced by the hypothalamus. But how do these hormones find themselves to the anterior pituitary gland, and how do these hormones find themselves to the targeted organs? So it is via what is known as the hypothalamic hypophyseal portal system. Okay, they use a portal system to find themselves. The hormones that are produced by the hypothalamus, they will use the portal system, which is this, the one showing, the one you're able to see as red and blue. This portal system, so the hormones will be, the releasing hormones will be released in the portal system. And then the portal system will take these hormones to the anterior pituitary gland. And then the anterior pituitary gland will be able to release the hormones that are supposed to be released. Okay? So when you get the notes, I think for this one, I've already explained the basics. So it's when you read this, it's straightforward. Okay? Regulation of the hypothalamic and the pituitary hormones. Regulation, very important here. Okay? Regulation. And let me go back to this diagram. Okay? We now know that these are the hormones being produced by the anterior pituitary gland, and these are the hormones being produced by the hypothalamus. Okay? How are these hormones regulated? They are regulated by the hormones produced by the targeted organs. I'll give an example. Thyroid. When TSH is released, it goes to the thyroid. The thyroid will be able to make a lot of T3, T4. This can regulate the production of TSH and the production of TRH. Whenever T3 and T4 they are in large numbers, they give a negative feedback. There is a negative feedback to the hypothalamus telling that we're a lot. This is enough. Can you stop producing your thyrotropin releasing hormone? Okay, can you stop producing your thyroid stimulating hormone, because we are a lot of us. There is a whole lot of T3, T4. So in short, whenever there are high levels of a certain hormone, it will give a negative feedback to the hypothalamus, which will then give a negative feedback to the pituitary gland. The same thing can be said with the cortisol. Cortisol is produced when you have ACTH stimulating the adrenals. When there is high levels of cortisol, it gives a negative feedback to the hypothalamus to stop producing corticotropin releasing hormone. And in return, when this is low, it means there will be less stimulation of the anterior pituitary gland, and then there will be less of this. And when there is less of this, it means cortisol levels will be going back to their normal values. So in short, even the estrogen, progesterone, and testosterone, you know that they will go and inhibit the gonadotropin releasing hormone, of which when this is inhibited, there will be less production of LH and FSH and less production of those very same hormones. So that's basically how regulation gets to happen. It's as simple as eating porridge. Okay. All right. Any questions before I move? We are good. We started with 53 people and have 19 people. It means it's bad for those that have left, but those that are in class, are we all good? Because I always emphasize to say that if you're not clear, you should ask. Okay. So let's move on now. I want you, about this particular point, you're familiar. So these are the hormones that are produced by the hypothalamus. These hormones are called what? Releasing hormones. You can see there is an R in each of the hormones. Corticotropin releasing hormone, thyrotropin releasing hormone. You should know where they are going to they are all going to the anterior pituitary gland, but what are they going to stimulate? So corticotropin releasing hormone, they are going to stimulate SLH, TSH, LH, and FSH. And then this one is for the growth hormone. It's going to stimulate the growth. The growth hormone releasing hormone is going to stimulate the growth hormone. Now, the reason why I added this diagram is I want you to know how these hormones, so they are going to the anterior pituitary. They act on the receptors. You are going back to signal in transduction. When they act on the receptors, what type of second messengers do they produce? Those are MCQ questions that might come. So here, there's nothing like understand. Just memorize. Memorize to say corticotropin releasing hormone, when it goes to the anterior pituitary gland and acts on the receptor, it uses CAMP. While this one uses IP3, so it's a matter of memorizing here. You will find some of these in your MCQs, okay? So I just want you to memorize, nothing to understand. Time for understanding, especially on this, is gone. But I think you will understand because you have to revise that topic. We did it in term 1, okay? To make it interesting now, let's try to answer some questions, because I might just be teaching and you might think like, just teaching is not really as nice. So let's try to see if we can answer some questions, and I want it to be interactive. I want all of us to participate, okay? So it's an MCQ question. Question 1. Releasing hormones produced in the hypothalamus. Hey, these are true or false. Hey, I know your... Okay, now I've already explained the pituitary gland in detail when I was doing the first part of it, so I'll just peruse through here, okay? There are specific things you need to know about the pituitary gland, but I was mostly focusing on the hypothalamus when I was teaching my first. So I'll now peruse through the pituitary gland, and then we talk about some of the hormones that are produced. Some of these hormones, you'll read them under, for example, thyroid, TSH, you understand it fully under thyroid gland. ACTH, you understand it fully under adrenals. Okay, here I'm going to talk about two hormones that are never talked about anywhere else: prolactin and growth hormones, and then we'll call it a day. Okay, the pituitary gland. So the development of the pituitary gland, I did mention where it is developed, and that this is a question that might come in your anatomy as well as you're preparing for your exam, because you did your pharyngeal apparatus. Okay, remember that the pituitary gland has two parts: the anterior and the posterior. The anterior, I said, it comes from the pharyngeal apparatus. Where on the pharyngeal apparatus? It comes from the nasopharynx, okay, and this part of the nasopharynx is derived from the ectoderm. Sorry. So I'll repeat: the pituitary gland is divided into two, anterior and the posterior. The anterior part comes from the pharyngeal apparatus. Where exactly? The nasopharynx. Where does the nasopharynx come from? It comes from the ectoderm. Okay. Mukape likes it by using my fancy name, so you might just use this word here. That is where it comes from. That is under the pharyngeal apparatus. You know, it has pouches. Now the pouch where the anterior pituitary gland comes from is called Rathke's pouch. Okay. Then the stalk and the posterior pituitary gland, like I mentioned, they come from the neurotube, the neuroectoderm. Okay. So that is where they come from, and that is why I said that the posterior pituitary gland is just considered to be an extension of your hypothalamus, because as the hypothalamus is growing, it starts extending, and it's the one that becomes the stalk and the posterior pituitary gland. And that is why the hormones that are found in there, oxytocin and vasopressin, they are said to be produced by the hypothalamus. Hormones produced by the anterior. So since the pituitary gland, the posterior pituitary gland is not considered to be part of the pituitary gland, but part of the hypothalamus. It means here you'll notice that when I was talking about the hypothalamus, we concentrated mostly on the posterior. But now when I'm talking about the pituitary gland, I'm going to concentrate on the anterior, because the anterior pituitary gland is the true pituitary gland. It is the one that produces those hormones that will go and act on different endocrine organs. Okay, so FSH and LH, which cells produce FSH, and now we need to know. Okay, remember I wasn't talking about these cells here, but now we need to know. FSH and LH are produced by cells known as gonadotrophs. It means the gonadotropin releasing hormone from the hypothalamus is the one that stimulates the gonadotrophs to produce FSH and LH. Meaning TSH is produced by the thyrotrophs. Again, it means the thyrotropin releasing hormone coming from the hypothalamus, it is the one that will stimulate the hierotrophs to produce TSH. The growth hormone, this is growth hormone, it's produced by lactotrophs. Again, I want you to know. Okay, the cells that produces growth hormones are called lactotrophs. They respond by when the hypothalamus produces growth hormone releasing hormone, which stimulates the lactotrophs. Okay, then prolactin is also produced by the lactotrophs. Okay, then you also have this hormone here, which is known as POMC, pro-opiomelanocorticotrophic hormone. Pro-opiomelanocorticotrophic hormone. Remember what I talked about when I was talking about melatonin and ACTH. I said corticotropin releasing hormone that comes from the hypothalamus. It goes to the anterior pituitary gland and it will stimulate the cells. Now the cells that are stimulated are called corticotrophs. These corticotrophs will produce two hormones, melanotropins and corticotropins. Melanotropins will be used for sleeping cycle plus the hyperpigmentation. Corticotropins are the ones that goes for the adrenals. Okay, so this is your POMC. Okay, the POMC, pro-opiomelanocorticotrophic hormone. Okay, so you can see these are the branches. So this hormone, it has ACTH, it has melatonin stimulating hormone, plus the enkephalin and the beta enkephalin and the beta endorphin. But the ones I'm interested in for you to know is ACTH and MSH. So you've already seen the question. You will see some of the questions coming. Okay, so an increase in ACTH. Whenever ACTH has increased, what you should also have in mind, whenever you see a question talking about ACTH increasing, know that your melatonin stimulating hormones also increases. So anything that will cause increase in ACTH also causes the increase in MSH. And now this, you use this per word, guys. If someone has a disease that causes an increase in ACTH, we can easily trace them out because they are usually hyperpigmented. They will be black. They will have pigmentations because anything that causes increase in ACTH also stimulates the melatonin stimulating hormones hormone, which also act on the melanocytes to cause the overproduction of melanin. So people who have a lot of ACTH, they will end up being hyperpigmented, black. The lips will be black. Not everyone who is black like that has this problem, but it's one of the things we do use power to actually differentiate. Okay. Classification of hormones. So we can classify, now remember talking about the anterior pituitary. So classification of the hormones of the anterior pituitary. So it can be based on the structure or it can be based on the mechanism of action. Okay. So based on the structure, you need to memorize as you are going for exam to say TSH, FSH, LH are glycoproteins. Then growth hormone, prolactin, and ACTH, they are polypeptides. And you need to memorize the number of polypeptides. For growth hormone, it's 191, prolactin 199, and then ACTH is greater than 260 amino acids. So you need to memorize. There are no two ways about it. Okay, you just have to know. Okay. Then based on the mechanism of action. So based on the mechanism of action, are they using CAMP? Are they using JAK-STAT? You know, these are now signals to see how they get to stimulate the cells that are getting. Basically, are they going to use a CAMP? Are they going to use whatever they're going to use? Okay. The relationship of the hypothalamus and the pituitary, anterior pituitary gland. I think this I've already mentioned here. Okay, this is just talking about the very same things I already talked about. Okay. Okay. Prolactin. I will just need to emphasize on prolactin. Prolactin is the only hormone that is under inhibitory control of the hypothalamus. Prolactin inhibitory factor, also known as dopamine, produced by the hypothalamus, regulates prolactin. I want you to take note of this. We've already seen some questions, and the more questions are yet to come under this. Okay. What inhibits the growth hormone? What inhibits growth hormone? Release. Somatostatin. And I want you to pay attention as you study to say that somatostatin is also released by the pancreas, the delta cells of the pancreas. Remember, pancreas has alpha cells, beta cells. Beta cells are for insulin. Alpha cells are for glucagon. Delta cells they are able to produce somatostatin. That somatostatin that is produced by the pancreas, it can also cause the inhibitory effect on the pituitary. And that is where this statement comes in, okay, to say the only thing that gets to control prolactin release in our body is the hypothalamus. But it cannot be it's not the same thing with the growth hormone, despite it also being controlled by the hypothalamus via somatostatin. Somatostatin is also released by the pancreas, which can also cause the inhibitory effect. And that is why this come up, the only hormone under inhibitory control of the hypothalamus is prolactin, because it is the only. If you remove hypothalamus, there won't be any organ that can control the inhibitory release. Okay. Posterior part I've already mentioned. So these are not the other part of the session. It's like now we're just summarizing what we talked about. You already know the relationship between the posterior and the hypothalamus. I think I even mentioned, refer to the notes on the hypothalamus for great details. So on above. Okay. Okay, so I now want you to, this is blood supply of the pituitary. I need you to know this, both in your anatomy and your physiology. Okay, superior hypophyseal artery, where it is going and which type of plexus it will form. Remember, this obviously is going to the anterior pituitary gland. Then the inferior hypophyseal artery is the one that goes to the posterior pituitary gland. So the oxytocin and the oxytocin and what? The oxytocin and the vasopressin. When they are released by those neurons, they are released into this plexus here. While those anterior ones, they are released into this plexus here. Okay. Physiology of the anterior pituitary gland. Okay. You need to, now this is embryology from Kape. Take note that it will start working the corticotrophs. Okay. The corticotrophs that are released on the anterior pituitary gland are the first cells to appear at 6 weeks of development. This is from Kape, take note, okay? Transcription factors are required for the release of the anterior pituitary hormone. What we mean is, remember we have the releasing hormones, right, coming from the hypothalamus. So those releasing hormones, they for these hormones to be synthesized, the ones that are in the anterior pituitary, you need some transcription factor, meaning you need hormones coming from the hypothalamus so that they can stimulate the nucleus of those cells to start synthesizing these hormones. So you need a transcription factor that can only be there if the hypothalamus releases those releasing hormones. Okay, that's what we are saying here. So pituitary hormones, how do they work in terms of signal transduction? Remember, these hormones are now targeting the thyroid gland, they're targeting the adrenals, they're targeting the mammary gland and the like. But how do they work? Okay, so here they are now showing you how they get to work. Eventually, all of them, they end up using CAMP. Okay, so you can see adrenocorticotropin hormone. If it goes to the adrenals, eventually CAMP is what they are going to use so that the adrenals can release cortisol or androgens. Thyroid stimulating hormone, CAMP, is what is going to be used. The LH and FSH, CAMP. An exception, and I want you to take note, are these two. Remember, these ones are not targeting any organ, they are targeting tissues. So they use JAK-STAT. Just memorize the JAK-STAT. There's no need of you to start stressing yourself. Okay, and then this is a beautiful table showing you the staining. You need to know the staining. Okay, the number of cells you need to memorize that somatotropy, they are about this much. So in short, memorize this gamma table, diameter and everything. You need to know. You know how physiology is. I'm sure at this point you know. And you need to know the staining, especially in anatomy. Mukape would ask, I don't know if you learned, but the third years did. He usually brings these staining issues and the like. So you need to know that the thyrotropes are basophilic, gonadotropes they are basophilic. Then these others are acidophilic. You need to know this. Okay. Questions. Surgical removal of the pituitary gland is likely to lead to a decrease in A. Plasma osmolality, B. Menstrual frequency, C. Axillary air, D. Sexual desire, E. Breast size. We are now on questions. Just trying to do a quick recap. This has been a longest lecture, but I hope it has been. I think it has been helpful. It has, right? It's been helpful, right? It has, I'm sure. So let's try to answer some questions so that we close the chapter and you guys can study. Okay, so let's try to answer question 1. Surgical removal. Let's assume they remove the pituitary gland. What do you think might decrease? That's what they're asking. Is it the plasma osmolarity? Do you think the plasma osmolarity would decrease if they were to remove the pituitary gland?
No.
Why? Yes.
Because it's controlled by the hypothalamus.
The hypothalamus. So remember, Okay, Deborah wanted to say something. You can go ahead, Deborah.
I wanted to ask, like, it's the way that is present by the hypothalamus, but it is stored so that it is removed. Where do they get to this?
Okay.
Who gets to be affected or
Okay. So I want you. That's a very good question. Now let me answer it. The key word in your question is surgical removal. Okay. Surgeons, they know anatomy in and out, and whoever likes anatomy most likely will become surgeons, especially if you like memorizing structures. Okay. Now they know anatomy. It means they know the embryology of your pituitary gland. They know that the pituitary gland has two parts, the anterior and the posterior. They know that anterior is coming from this structure and the posterior is an extension of the hypothalamus. So when they are doing surgery, they only remove the anterior, they never remove the posterior. So surgical removal of the pituitary gland, just think of scrapping out the anterior pituitary gland. Remember the posterior and the stalk, we said they're coming from, it's even written here. Stalk and the posterior pituitary, they're coming from the neuroectodermal derivative. Meaning when the surgeons are doing surgery, they never remove this part. They only remove the anterior, which comes from the different part. Now that I've oriented you, let's see if we can answer now this question. Surgical removal of the pituitary gland is likely to lead into a decrease in A. Cannot be true. Right? If the plasma osmolarity has nothing to do with the pituitary gland, it's the hypothalamus. Menstrual frequency. True, right? Because your LH and are produced by the anterior pituitary. Axillary hair. Axillary hair is true. Remember, ACTH, adrenocorticotropin releasing hormone. It is produced by the anterior pituitary gland. So if you remove it, you won't have that, and it is needed for you to produce your androgens. I said in females, for them to have their axillary hair, it is because of that ACTH. Sexual desire, libido. True or false? Why? Why false? Or someone who said false? You know, when there's a hormonal disturbance, hormones are what causes the feelings you get to have is because of hormones. You know, when you're having sex, there are a lot of hormones. Don't confuse the oxytocin and what I talked about. No, but hormones have a lot to play in terms of libido and the like. So it would be true. Breast size. Breast size. Why are you saying it's true?
Because of the growth hormone, it will be affected because of that.
Okay.
Or maybe the FSH and the luteinizing hormone.
The LH and the FSH, we say that are getting the gonad, which is either the testes or the ovaries. Then the growth hormone does not target the mammary gland. It targets the growth plates, which is the bones and other things we talk about them. Okay, so the growth hormone has no effect on the breast. The LH and FSH have no effect on the breast, but the hormone that has an effect on the breast is thingy. Oh yeah, sorry, you are right. LH and FSH have an effect on the breast via estrogen. So because these two hormones, FSH and LH, are the ones that stimulate the gonads to produce estrogen. In return, estrogen is the one that will cause the increase in breast size. Okay, remember, increase in breast size, it is estrogen. Production of milk is prolactin. Then secretion of that milk is oxytocin. So E will be true. For the breast to increase in size because of estrogen, and estrogen is produced because of LH and FSH. So if you remove the anterior pituitary gland, you won't have your LH, FSH, and you won't have your estrogen, and the breast size won't be as big. So E was true. Melatonin, A, is produced mainly in the intermediate lobe of the pituitary gland. B, is synthesized in the body from serotonin. C, affects the level of pigmentation in human skin. D, blood levels are highest during the night. E, influences the secretion rate of the pituitary hormone. So I'll give this as a homework for you to actually answer. In a case where you have issues, each of you can inbox me this question. I want you to find answers after reading about the melatonin, okay? But remember that melatonin, what produces melatonin is the pineal gland. That's what I'll mention. Pineal gland is what produces melatonin. But pineal gland can only produce melatonin in the presence of melatonin stimulating hormone. And I said the melatonin stimulating hormone plus ACTH, they are both produced by the same cells when you have corticotropin releasing hormone coming from the hypothalamus stimulating those cells. Okay. Quickly, Prolactin. Prolactin, remember, Prolactin is a hormone that does not have any endocrine organ. It goes straight to the tissue. What tissue are we talking about here? Obviously, it is the breast. It has nothing to do with the size of the breast, but it's only there to cause production of milk. Okay, so where is it produced? So it is produced by the anterior pituitary gland. Okay, it is an amino acid that has it is a polypeptide that has 199 amino acids. Okay. The cells that produce prolactin, they make about 10 to 30% of the anterior pituitary gland. Okay, where this hormone is produced, it is produced within the lateral wings of the anterior pituitary gland. Okay, so all hormones are under positive trophic effect, but prolactin is under inhibitory effect of dopamine. I think I mentioned this. Okay, other sites that gets to produce prolactin other than what we've mentioned here, in a pregnant woman placenta, the uterus. Okay, and other parts of the central nervous system they get to produce prolactin. Now I want you to take note that prolactin release is higher when you are sleeping. Prolactin release is very high when you are sleeping. Okay, take note of that. There are a lot of MCQs on that. Hormones that stimulate prolactin release, the hormones that stimulate the release of prolactin includes estrogen, TRH, VIP, and oxytocin. Okay. Actions of prolactin, like I said, there is no role in the breast development. It's only used to for lactation, production of milk. Okay. This is what I wanted. Hyperprolactinemia. What does it mean? High levels of prolactin in blood. Okay. So hyperprolactinemia. So you need to know the normal values of prolactin in blood. So normal values should always be less than should always be less than 25 milligrams per liter. That's normal. Anything that is more than 100 milligrams per deciliter, it becomes, you might start thinking there is a cancer in the pituitary gland. That part of the pituitary gland that is producing prolactin, probably there is a cancer, and that cancer is now producing a lot of prolactin whenever it is this much. You start suspecting this. When it is more than 200 milligrams, it confirms that someone has a cancer. Whenever prolactin levels are more than 200 milligrams per liter, it's a confirmation to say that you are in a cancer, and that cancer is actually right there in the anterior pituitary gland, and then it has affected the cells that produces prolactin. So they are producing prolactin in large numbers. Okay. Then there is what is known as the physiological hyperprolactinemia, meaning physiological, meaning it's normal. If you find the levels of prolactin between 25 and 40 milligrams, don't rush to say there's something wrong with the person. It's usually physiological. You only have issues when it is beyond the 40 milligrams. Remember I said hyperprolactinemia is above 25. But between 25 and 40, it is called a physiological hyperprolactinemia, meaning normal. It's normal to find such high levels of prolactin in someone. But if it exceeds above 40, starts thinking there might be something wrong. Why is prolactin high in this person? Okay, so you can see this physiological, there are questions on this. You can see this physiological hyperprolactinemia in pregnancy, someone who is stressed, when you are sleeping. Remember I said that the prolactin levels are high when someone is sleeping. Okay? Or when you're stressed, like in your case you're about to write your exams, you're stressed. If you were to check your prolactin levels, you'll find that they'll be between 25 to 410 milligrams. And I shouldn't conclude to say that there's something wrong with you. Just stressed with your exams. Okay? Causes of hyperprolactinemia that is beyond 40. Remember, between 25 to 40, we said it's normal, and these are the things that can cause the physiological hyperprolactinemia. Now, the pathological, meaning the abnormal, above 40, it's abnormal. What can cause high levels of prolactin above 40 milligrams to 100? Drugs. What type of drugs? Drugs like risperidone. Okay, just memorize it. Just know there's a drug called risperidone, and if you ever see it in your question, what you should have in your mind is high levels of prolactin. The drugs that I put in your brackets, they do the opposite. Bromocriptine and carbagolin, they do the opposite. They decrease the levels of prolactin. So memorize it as such. Hypothyroidism. Hypothyroidism causes the hyperprolactinemia. The answer lies here. Hormones that stimulate prolactin release. One of them was what? Thyrotropin releasing hormone. Remember, thyrotropin releasing hormone is produced by the hypothalamus. It is high when someone has hypothyroidism, meaning low T3, low T4. So when someone has low T3, low T4, you have high levels of TRH, which will again stimulate your pituitary to produce TSH. In return, because this can also stimulate the cells that produce prolactin, even prolactin will be high. This, guys, never should you forget, please. Okay? So hypothyroidism can cause hyperprolactinemia. Then there's another disease called, there's a question. Yes, go ahead with someone with a question. Faith, I don't know if it's... Yes, go.
Yeah, I haven't got on the first point.
Which first point is that one? The one for hypothyroidism.
Yes, sir. On the drugs, people might know that I haven't understood.
No, I was saying here we're talking about causes of. Remember that the heading here is hyperprolactinemia, high levels of prolactin in blood. So we say prolactin is high in blood whenever it is above 25 milligrams per deciliter. If it is below, it's not high. Whenever it's above 25 milligrams per liter, we are going to call it hyperprolactinemia. Okay. Now, this increase in prolactin can either be physiologic, meaning it's normal. Physiologic is normal because maybe you are stressed, or maybe someone is pregnant, or someone is lactating. Those women with kids. Okay. If you find high levels of prolactin that is between 25 and 40, it's normal to see it in a stressed person like yourself. Someone who is sleeping, if you look at your roommate who is sleeping, they have high levels of prolactin in their blood as we speak. Okay, so it's normal. But prolactin levels that are above 40 to 100, it's abnormal. Now we want to find out what could be the possible causes of hyperprolactinemia that ranges between 40 to 100, because we know between 25 to 40 it's normal. Like it's a physiological hyperprolactinemia seen in pregnant women, stressed person. But what about that hyperprolactinemia that is between 40 to 100? It's not normal. What could be the possible causes? So now we started listing them out. It could be maybe drugs. Someone who is taking a drug known as risperidone can end up having having hyperprolactinemia that ranges between 40 to 100. Then I mentioned to say bromocriptine and cabergoline, they do the opposite. They causes hypo. They lower down the levels of prolactin. Then hypothyroidism, it also causes hyperprolactinemia that ranges between 40 to 100. Then I went on to explain how hypothyroidism causes what? Hyperprolactinemia. It goes back to this. Hormones that can stimulate the release of prolactin. One of them is the thyrotropin releasing hormone. Remember, thyrotropin releasing hormone ideally targets the TSH production. Then TSH will target T3, T4. Okay. Now, hypothyroidism meaning you have low T3, T4. Low T3, T4 will stimulate the thalamus to be producing more of this. More of this will stimulate more of this. But we are saying TRH also stimulates prolactin. So the cells that are producing prolactin will also be stimulated. So we also have high levels of prolactin. So we are saying hypothyroidism can be a cause of hyperprolactinemia. Never should you forget that. Okay. Another cause is polycystic ovarian syndrome. Just memorize it like that. Liver disease. Someone who has liver disease can end up having what is known as hyperprolactinemia. Plus another drug called alpha-methyl-dopa. Let's try to answer a question as always. Now this is a scenario question and it will cement. A 40-year-old female patient with bipolar mood disorder is taking lithium carbonate, which decreases thyroid hormone secretion. On routine monitoring, it is noted that the patient has hyperprolactinemia. This is your question, your second, third year question. A. Discuss the physiology of the raised prolactin in this patient. If you've understood what I've said, you can try this question out. Let me read the scenario, and then you can try the question out. A 40-year-old female patient with bipolar mood disorder. So this patient has a disease called bipolar. Then the patient was given a drug known as lithium bicarbonate, so they can treat the bipolar. But this lithium decreases the thyroid hormone secretion. So on routine monitoring, it is noted that the patient has hyperprolactinemia. The first question is saying, discuss the physiology of the raised prolactin in this patient. Anyone to try it out? We're almost done, by the way. If you have been awake with us and you've been listening to what I've been saying, how would you explain A? Yes, Mono, go ahead.
A decrease in thyroid hormone secretion causes a positive feedback on the hypothalamus to secrete thyrotropin releasing hormone, which in turn causes the production of prolactin, which causes hyper.
Exactly. I added this scenario again. This scenario question is straight from your past papers. Okay, straight from your past papers. I just copy pasted it like that. I remember that the key point is that This patient has hypothyroidism. How did it come about? It came about because the patient was given this drug called lithium, and wakuuza here to say it decreases the thyroid hormones secretion. So in short, they're indirectly telling me that this patient has hypothyroidism. And based on my explanation, hypothyroidism naturally will tell the hypothalamus to start producing a lot of TRH, thyrotropin releasing hormone. In return, the thyrotropin releasing hormone will obviously stimulate the production of TSH, but not only TSH, it will also overstimulate the production of prolactin. So this patient will end up having high levels of prolactin, and obviously they will have high levels of TSH as well, but we're not really interested in TSH, we're interested in prolactin, which will end up causing hyperprolactinemia. That is the physiology we wanted you to talk about under A. I don't know which intake, I think 2019, 2020, whoever wrote this paper, that's what they wanted to say. B, give 2 signs of raised prolactin. So if someone has raised prolactin, how would you tell? Okay, I'll give you one example. They'll be producing milk. Someone doesn't have any children, they're not pregnant, but they're producing milk. Okay, it's a sign that they have hyperprolactinemia. But I want you to find out the second sign. It's your homework for you. Which drug should you prescribe to lower the prolactin levels? The answer again, I've mentioned it here. Someone to guess it out. If you're able to remember, okay, I cannot remember the drug. If you're able to remember the drug, you can mention it. But if you're unable to remember the drug, the name, you can mention the first letter of that drug, the drug. What letter does it start with? Excellent. Bromocriptine. Never should you forget bromocriptine. Bromocriptine is a synthetic dopamine. Remember dopamine, we said that inhibitory effect. It has an inhibitory effect on the prolactin released. So bromocriptine is a synthetic dopamine. So when you give bromocriptine, it will be inhibiting those cells so that they don't produce prolactin. Hence, you are controlling your levels of prolactin in that. So that's either of the two. If you mention either bromocriptine or cabergoline, you'll be able to get the marks. But the easiest one to memorize and the one that pops up in questions mostly is bromocriptine. With the help of the diagram, show how this drug in question will lower the prolactin. So it's a matter of drawing the negative feedback, how it will go and inhibit, how it will inhibit the pituitary cells from producing prolactin. That's what they wanted here. That is my diagram in my thingy. But instead of it coming from the pituitary, it's a drug that will just inhibit the pituitary. Just like a malo going to the pituitary with a negative, like that. Okay. Yeah, this is the last one, guys, and we call it a day. Growth hormone. So growth hormone, I've already mentioned everything, but I want you to take note during sleep. I've already mentioned everything here. It increases during sleep. Okay, I want you to take note. Just like your prolactin, it also increases. There are MCQ questions here. Now, this is very important. The half-life of growth hormone is just 5 to 20 minutes. So because of that, you cannot measure it just like the way we are measuring the prolactin. We're able to measure prolactin. You cannot measure growth hormone like the way we measure prolactin in blood. We don't even know how much it is in blood because its half-life is between 5 to 20. By the time you measure it, it would have dissipated. Like the half-life of this hormone is very short. Okay, so instead of measuring the growth hormone in blood, we actually go for another hormone called insulin-like growth factor. Insulin-like growth factor. So it so happens that when growth hormone is released in blood, it will go to the liver and stimulate other cells in the liver so they can produce another hormone, and that hormone you call it as insulin-like growth factor. It is the insulin-like growth factor that does most of the functions of the growth hormone. Remember, growth hormone doesn't stay that long. So in that shortest period of time, it goes to the liver and stimulates the liver to produce insulin-like growth factor, which has a long half-life. So at the ward or at the clinic, we actually, if you want to know if someone's growth hormone is working, we don't measure growth hormone, we measure insulin-like growth hormone because it is produced by when growth hormone is released. So that's what we measure. Stimuli for growth hormone production. What stimulates the production of growth hormone? Hypoglycemia, meaning when you have low levels of glucose in blood. Ghrelin, this you should know because it's under your GIT. And the growth hormone releasing hormone from the hypothalamus. So these are the things that can stimulate the production of growth hormone. Factors that inhibit growth hormone: somatostatin. Okay, somatostatin, remember I said it's also produced in the pituitary, or in the hypothalamus, it's also produced in the pancreas. Age. A 15-year-old is able to produce a lot of growth hormone as compared to us who are 27, 28, or you guys who are 22, 23. Okay? Obesity also decreases. Obesity does the somatostatin decreases, aging will decrease, obesity will decrease. Okay? TRH in a normal person does not increase growth hormone levels. In the presence of growth hormone secreting tumor, TRH increases the growth hormone level. So they are saying, in a normal person, TRH never stimulate the pituitary to produce growth hormone. But some people who have cancer of the cells that are able to produce growth hormone, TRH can actually stimulate those cancer cells and then they can produce growth hormone. It's called paradoxical growth hormone release. Okay? So the insulin-like growth factor, remember where it's coming from the liver, right? That's what I said, it's coming from the liver. Remember, this only exists when you have your growth hormone. But growth hormone life expectancy is 5 to 10, 20 minutes. So before it disappears, it goes to the liver and stimulates the liver to produce insulin-like growth hormone, growth factors. There are two of them. There is they are abbreviated as IGF, fine. IGF-1 and IGF-2. IGF-2 is only seen in fetus. Only used by the fetus, those that are still in the mother's womb. IGF-1 is the one that is produced by the liver, the one we use as any human being, for them to be able to use up for their growth. The growth hormone goes to the liver, stimulate the liver to produce insulin like growth factor 1, which is also called somatomedin. In your MCQs, they like using this one. Somatomedin C, produced by the liver. The regulation of this somatomedin C, they are regulated by the growth hormone, of which in turn the growth hormone is regulated by the hypothalamus. So the IGF-1 is responsible for most of the peripheral actions of the growth hormone. Remember, growth hormone itself, life expectancy is short, but it uses IGF to do the rest of the function. So you need to know the functions of growth hormone. You will be finding some of the MCQ. So direct actions of growth hormone. By direct actions, we mean if you have your growth hormone, it goes to a tissue. What does it going to do? Okay, so protein synthesis. Protein synthesis, both the growth hormone plus its derivative IGF-1, they cause protein anabolic, meaning synthesis of protein. Carbohydrates, growth hormone decreases insulin sensitivity, meaning it promotes gluconeogenesis, in short, instead of glycolysis. Gluconeogenesis is promoted because glycolysis means you have to take up glucose. But what growth hormone does is that it decreases the sensitivity of insulin. When you decrease the sensitivity of insulin, means you are doing the opposite. You are encouraging glucagon to come up with, to promote gluconeogenesis. Okay, lipids. Growth hormone, as it breaks down the lipolysis. You need to know these, guys. Okay, these are the things you will see in your MCQs. So overall, this gamma diagram shows you the functions of growth hormone. Okay, these are direct functions of growth hormone. On the bones, what does it do? It works. It goes to the epiphyseal growth plates and causes the increase in the bones. Okay, protein synthesis, lipolysis, decreases insulin sensitivity and sodium retention. But there are times, because its lifespan is just 5 to 20. Before it even does everything, it disappears. But it would have stimulated the liver to produce IGF-1. And IGF-1 will continue with the functions of growth hormone, which is this, and this. Okay? Lastly, this is the last page. We are done. That has been a long lecture. But I hope I've helped out in preparation for the exam because, yeah. Acromegaly is a fancy term to say high levels of growth hormone in blood. High levels of prolactin in blood, we call it as hyperprolactinemia. Okay, but there is no proper name for high levels of growth hormone. So we call the disease is called acromegaly. Okay, so acromegaly just means you have a lot of growth hormones in your blood, or you have more than normal levels. Okay. The causes of high levels of growth hormone, obviously the first thing you should think of is a tumor within the pituitary gland. Okay, if not for the tumor within the pituitary gland, it can be maybe a tumor in the pancreas, maybe a tumor in the bronchi. These are the places you can have those tumors producing a lot of growth hormone. But the point here is, I didn't add. I want you to Google acromegaly when you are done. Google acromegaly, you'll see giant. If you ever see, if you've ever seen pictures showing giant people who are very tall with big feet, they're just giant people. That's the disease we call as acromegaly. someone is very tall because the epiphyseal plates are ever being more stimulated, and the person has been growing and growing and growing. They're not, there is a limit. There is no limit for them. So that's what requires acromegaly. I thought I added the picture, but I didn't add. So I want you to Google that. We are done now. So I added some to my question. I think this to my question, you can answer them on your own. A pituitary tumor secreting excessive growth hormone in an adult may lead to. So I want you to answer this to my question on your own at your own time based on my explanation here. Impaired growth hormone secretion. Again, I want you to answer these questions. Okay. During sleep, there is 4 in the secreting levels of. Again, I want you to answer these. All these questions are straight from your past papers, and they are not from anywhere but your own past papers. So if you're able to answer these, despite your exam having best, remember the very same questions can be best true by just twisting and putting one correct answer. Okay. So that is it for today. That is it. It has from 21 to 24. That's 3 hours to 4 hours. Longest lecture I've ever had. But I'm really hoping that it has been helpful. Do you have any questions? Okay. So if there are no questions, we can call it a day, guys.
Excuse me.
Let's go. How do we access the notes? Oh, you are not part of. Is this your first time attending our classes?
Yes, sir.
Oh, okay. So, okay. Are you part of MMRS groups?
Yes.
Okay, if you are part of the MMRS groups, there is a technician usually post in the group on how. So there are people that